Hi and welcome to another vectors video on Kirby Maths. This one is all about proving that 3 points lie on a straight line using vectors, and the first thing that you must be aware of if you are asked to do this is you must never ever trust the diagram. The diagram will show that they are on a straight line or might show that they're not on a straight line, but you have to use vectors to prove it. So the first point is never trust the diagram. Okay, and it will say not to scale or something on the side. Okay, second thing is there are two facts that we need to use in order to do this, and it's the same thing every single time. So once you get used to using these two facts, then it's a very simple process to prove that 3 points lie on a straight line using vectors. The first fact is that if vectors are multiples of each other, they are parallel. So for example, if we have a vector which is represented like this using unit vectors a plus b, and we have another vector which is 2a plus 2b, if we factorize this, it's 2 lots of a plus b. This is a multiple of this original vector. These two are parallel. It doesn't always have to be a whole number in front of this. It could be a fraction, 1/3 of a plus b. And it could even be a minus sign if you had a vector that was described like this in your final workings, minus 5a minus 5b. If I factorize this and I take minus 5 outside the bracket, that becomes a plus b inside the bracket, then this is a multiple, albeit a negative multiple, of this original vector a plus b. It just means it's 5 times as long and it's going in the opposite direction, but that doesn't take away the fact that it is parallel. Okay, so if vectors are a multiple of each other, they are parallel, and this is important, and we're going to use this. The second fact is that if two parallel vectors start at the same point, then the 3 points, the start, the end of the first vector, the end of the second vector, are all on a straight line. So if two parallel vectors start at the same point, then the start point the end of vector 1 and the end of vector 2 are on a straight line. And if I show a diagram, that will help you out because it's a bit complicated. So this is a straight line. This I'm going to call O. This point here I'm going to call X, and this point here I'm going to call Y. If OX and OY are parallel to each other, that means they have the same gradient, so I could shift them up and down, and they would still be parallel to one another. If they are anchored at this point, at their start point, if they both share the same start point, then they must lie on top of each other. That's the only way they can remain parallel, and that means that these 3 points are in a straight line. So when we are trying to prove that 3 points lie on a straight line, the whole point of this video, what we have to do first of all is show that the vectors are parallel by saying they are multiples of one another, and the fact that they have the same start point gives us the final bit of our proof to say that they are on a straight line. So the method we need to use then is we need to show that OX and OY are parallel, i.e. they are multiples of each other, so you work those two out. You then write an equation linking OX and OY in terms of multiples of one another. So for example, OX 3OX is equal to OY. So OY is 3 times as long as OX. You could write this exact same thing as OX is equal to 1/3 of OY. It doesn't matter which way round you write it. You've got these being multiples of each other, so they are parallel. And then because they are anchored at the same point, because they start at the same point, it means that they are on a straight line. So you write OX and OY are parallel. And the reason is the multiple vectors, multiples of each other. Also, they start at the same point. Therefore, remember our little 3 dots, therefore O, X, Y lie on a straight line. And usually these sorts of questions are right at the very end of the paper and the GCSE paper, and they're not done terribly well. But when you break them down into these two components, the two facts, that if they're a multiple of each other, they're parallel. So you start off by showing that they're parallel, and then if two parallel vectors have the same start point, they're anchored at the same point, then it means that they are on a straight line. Okay, thanks for watching.